I'm sorry, I'm still hangover from last night. And I organize my own socials, so you're more than welcome to join me tonight. So this is a talk about data. This comes from really bad experiences I had. So one of the best examples I have, and why it's important to write good things, which apparently, what just happened? Oh, that's very cool. So the best example I have, so this is a bill from Amazon Web Services for $6,800. And if you can see right there, we made 6.8 billion requests to the queue service Amazon has. I think that happened in roughly 10 hours. It's pretty expensive. And why it happened? Because we wrote really, really stupid code. And usually people say computing power is cheap, so rather than wasting time implementing correct algorithms, you should just do whatever it works. This is a good example that you shouldn't do this. So we learned it, and we had to pay a lot. So my name is Joe. That's my name. I happen to have a very strange name, which people can't pronounce. So people call me Joe. You can try, usually I have this rule. I would say, if someone can pronounce my name, I would buy you a beer. Usually people can't. And second of all, we have free beer tonight, so why would I? But you can still try. So I do a lot of different things. I guess the best explanation of what I do is I'm an entrepreneur, so I build things and I make things happen. But my main passion lately, or for a couple, last few years, is data. So I really like to work with data and use data to make clever things happen. Because nowadays, there's so many things available, you can just collect them. So if you're interested in what I do and if you want to find out more stuff, and if you want to find more pictures of me, you can go to my website, I guess. This photo, this is actually not fake. This is me in Scotland wearing a kilt. It's pretty cool. What? No. And I was tying on my shoe once, and I just hear people laughing. I'm like, oh. This was my first time wearing a skirt, and apparently girls through years of experience learn how to sit properly and stuff. And I was just no. I said sorry to everyone who was with me because I probably flashed everyone a few times. So let's move on. This is not important. There is more important things. So what's the problem? Usually when you're building applications, whatever you're building, hello, you're late to class. Don't be late. Usually when you're building something, you start small. So whatever application you have, you start in small steps, build a simple interface. If you have some data processing, you do it locally, whatever. Small is fine. Eventually a problem happens as your application grows. If you're doing things right, your application grows, which is a very nice thing to do because all of a sudden you have more users, you're making more money, or the application becomes more successful. The problem though, all the small things you've done, which worked in a small scale, no longer work. For example, when you have so much data, it doesn't fit in a hard disk anymore. So you can do as many clever things as you want, it's not going to work. So why do you have this problem? Why do we have this problem where we build simpler solutions and all of a sudden they fail? Developers are lazy. And that's, I think the reason why developers exist is that people are lazy, so we created computer programs to make our lives easier. I'm extremely lazy, and I build things which make me not do things, which is very nice. The problem though is, because developers are lazy, we tend to build solutions which are really suboptimal. And what happens is it's too much. We can't handle it anymore. So we build solutions, and eventually we're trying to process so much stuff that everything fails. And that happens for everyone. Even at the scale of Facebook, even at the scale of anything, eventually you're going to build something so big that it's just not going to work. You're going to have some sort of report in your, say, a commerce system where you can click a button and it reports something, which used to work when you had, 1,000 orders. All of a sudden you're getting 100,000 orders a day, and that report doesn't work anymore. It's too much want. Also, no. I was advised not to make offensive jokes, so I try to avoid. So what happens is, rather than developers being lazy, the code should be lazy. Does anyone know what lazy code means? It's whatever the grading system is in France, you'll get 0. There's probably no 0 scales. Anyway, so what does it mean by lazy code? So imagine you want to build an array of numbers. Rather than computing that array at the definition stage, where you just say, I have an array. And so in PHP, when you say an array of, say, 1,000 integers, it would actually create a memory and fill that in with those 1,000 integers. Imagine being able to define infinite arrays, where you just say, I have an array of numbers which go from 0 to n, and it's just there. And the executor only executes that when it actually needs that data. What happens is, at no point in your application execution time, you have more data than you need for any certain step, which is very, very cool. So rather than allocating, say, infinite amount of numbers, which is actually impossible, who thinks it's possible to allocate infinite numbers? Unless you're like a MongoDB developer, maybe, web scale and everything. You can't allocate infinite number sets, but you can define them in a very abstract way, saying, this is my data set, it has a certain property, say it's infinite data set, or it's a database result, it's there, I don't know what it has yet, but I'm going to call it, and it's going to return me something. And once you do that, once your code becomes lazy, you stop pre-computing things. And in that way, you can actually scale. Who is here a PHP developer? Quite a few people. Who uses this function? You are all idiots. So what's the problem with this function? So the problem with this function is it's developers being lazy. This was created by, added to PHP, just because PHP developers, I'm a PHP developer myself, I'm not bashing PHP explicitly, so it was created to make life easier. I just have a file name, I read the file name, I pass the file name, I read a file, I have a string, I can process things as I go. The problem is, what happens if you have a 10 gigabyte file you want to read? It will read through everything, load everything to memory, and then you can process things. That happens to be extremely stupid, because as it's reading the file, as it's building everything in memory, you're doing nothing. Your CPU sits waiting as the disk is being read. And reading 10 gigabytes takes a while. Even with SSDs, it takes a while. So this is a really terrible thing to do. So we want to be lazy. We want to read the file without actually having to store anything in memory. And I'm going to show how to do that. So how it happens, you can use trains. This talk is partly about trains. Not really. So what is a train? So imagine, like in India especially, they have the really long trains, like kilometer long. Obviously, they don't wait for the whole train to get to the station so they can process that. That's impossible. Like you can't build a kilometer-long train station. I guess you could theoretically, but no one does that because it's just extremely stupid. So what you do is a carriage arrives, one of them, and you process that, and then another one arrives, and you process that, and another one arrives, and you process that. So a train can be infinite long. The length of a train doesn't matter because you're never processing more than one carriage, and that allows you to scale infinitely because a train can be one carriage, it can be 100, it can be 1,000, or a billion, thousand, million, trillions. It doesn't matter because you always process one carriage. The same thing applies when reading data. You always want to process only the single smallest unit you can have and leave everything else for the later stage. So what we're trying to optimize is wait times. When it comes to processing data, you tend to have a lot of it. And a lot of data is a very loose definition, depending on your domain, depending on what you're doing. Like in social networks, a lot of data usually means petabytes or tens and billions of rows. In e-commerce, it's usually a smaller number. So depending on your domain, depending on what you're doing, a lot of data is a different number. But you always want to try to make sure you're not waiting for things. Because when you wait for data to be processed, your CPU is sitting and doing nothing, and that's terrible. Another thing which happens, which is even worse, is memory usage. So imagine you want to process a 10 gigabyte file. Yes, nowadays you have big enough servers, and they're pretty cheap. You can buy a server with 16 gigabytes of memory. You can load one file, everything is fine. You can't scale that though. If a user uploads a video of, I don't know, 100 gigabyte, say, and you want to process that to do something, how you can do that? You can't, because you can't fit that in memory. That's a problem. It's a really, really problem. And even if you do smaller things, even like whatever you're doing, you're probably going to be doing smaller things if you want to do like a gigabyte, 100 megabytes, even 10 megabytes. If you try to load everything to memory, this happens. So this is like the best example of badly written applications, and that tends to be like the lazy written application. Is what happens is I have a lasers. At this stage, I'm starting to read a file, and I'm doing nothing else but reading the file to memory, and I'm doing something here, and then I process usually that file. I deallocate the array, so the memory usage drops. Then I'm reading something again, and I'm not doing anything else, but I'm reading something to memory. And usually, like in these sort of applications, you go to a server log, and you can see that saw teeth looking graph. It just goes up and down, up and down, up and down. The problem though, imagine in this case I read a file. I have it in memory. Then you're building a second array by processing this file string. You're building a second array with all the results. So all of a sudden, rather than just dropping, you keep growing. There's only so much you can grow. Also, if you have concurrent users, you can't grow anymore because this is just not going to work. At the same time, if you say try to load, I don't know, even like in PHP, even if you try to load 10,000 rows from a database, it's going to require quite some memory. And if you're using older PHP versions, which you shouldn't, but people tend to, if you're using older PHP versions, garbage collector doesn't work well, so you're going to just load everything to memory, and your PHP process is going to die. Who knows this? What this car is? What this car is? No. Who said Countach? Yes. We should like go out or something. This is a Lamborghini Countach. Actually, a very cool car. It's a very old one. It has nothing to do with the slides. I just put it in because we're going to talk about performance. So what happens is, once you have a lot of data, performance tends to be something is very hard to achieve because you tend to be bound by memory. So what happens is, the things I'm talking about, like reading something into memory, it's actually faster than anywhere else. If you have a file and you read everything into memory very quickly in a closed loop, it's the fastest way to do that. Once you start to spread that, it becomes slower. The problem is, you're always trying to balance memory and performance. It's a very application dependent. Depending on what you're doing, you might have problems or not have problems, but always think about that. If you're trying to optimize memory usage, probably performance is going to suffer, and that way around. So I called everyone an idiot for reading files. So let's talk about how to do it right. So let's say you want to read a CSV file, like a spreadsheet file. How do you do it right? There are different ways. There are different ways how to do that. The best way to do that is like this. So this is pretty much like the default way, the right way to read a file in PHP. So I define a file handler, and then I iterate through every single row, for every single line of that file, and I echo that to whatever it's running, and I just call the handle. In this case, I never have more than one row in memory. So that file can be as long as you want. It can be any size. It doesn't matter, because at this stage, I'm just reading one line. It reads one line. It returns me that, so it stores it in memory. I can echo it. I can do whatever I want. I can read it. It's fine. It doesn't matter like how big the file is. The same thing you can do for processing. So rather than echoing, every time you get a file line, you just process that, and it's fine. What happens with this approach? You can actually read videos. So a video tends to be split into frames. So you have a long video and there's a frame. So rather than loading the whole video and trying to figure out, for example, whatever you need to figure out, the color scheme, or you need to do something, you take a frame, you read up to a frame, and you process that. And again, a video can be any size, and the script still works. And like this is something we use a lot when it comes to processing spreadsheets, because people upload spreadsheets for whatever reasons. Rather than loading the spreadsheet to memory as an array and then processing that, we process every single line, and that becomes very, very fast. So you might be thinking, okay, I can read spreadsheets. I can read normal files because they're line-based. What happens if I have more complicated structures, which look to be not line-based? For example, XML. And I really like XML. So XML is arguably a pretty nice format. But the problem is, it's not line-based. So XML is a tree structure. So you can't just read any line and be able to interpret. You need to know the context, because if it's a multi-line node, you need to know all the parent nodes to be able to reconstruct the structure. Again, in PHP, you would usually use simple XML, and you would load everything in memory. Again, it works for really small cases, but actually consumes a lot of memory. It's incredible. So if you try to load anything bigger, all of a sudden, you just run out of memory, and that's a big problem. So what we want to do is we want to flow the XML in. In the same way, we read the normal file, reading every single line, processing every single line, or echoing every single line. We want to apply the same principle to reading XML. So how would you do that? It's actually very, very simple. Because what happens is, when you read XML, you only need to know the previous and the current node, and you can use stack traces to figure out where you're at. So PHP has this very cool extension. It's all, like all the examples I'm showing, it's all part of standard PHP. So there's nothing fancy. So what happened in this case, and the important bit is right here. What happens in this case, I create a DOM document, but the important object is the XML reader. So I have an XML file, and then I iterate through nodes. So this while loop goes through every single node in XML file. It just finds a new node, returns, finds a new node, returns, and keeps going and going and going and going. So as many rows as you have, as many nodes as you have, it keeps finding them. The cool bit though is, say I have an XML file, and it has somewhere inside of it a product node, and I know it's called the product. So I pick it. Once I find this product node, I take that node and read everything until that node finishes, so all the insides of that, and then create a simple XML object out of that, right here, and then I can do whatever I want. So in this way, I still have all the advantages of using simple XML, because I can still use object-oriented way to talk to XML, because otherwise it gets pretty nasty. But in this case, I'm only storing one product worth of XML data in memory, and everything else is being streamed to me, which is really, really cool. Because imagine someone submits to you a file, whatever the length it is, or you're reading an API. Imagine someone sends you a file, a gigabyte length. So you read, for example, first a few nodes. When you find some node and it says, oh, there's actually an error node present in the XML file, and you just like delete this variable, and all of a sudden you read the whole file without actually reading anything. It's really, really powerful. So XML reader, when it comes to reading XML files, is the best way. It reduces memory usage a lot. So if you're reading, especially XML APIs, it's a very, very fast way. And also, even if a file is being generated, you can configure that to kind of stream the file to you. It's really, really powerful. Another thing I like. So PHP is pretty, I guess, pretty slow when it comes to hard problems. So if you want to crunch through numbers, or you want to stream something from somewhere, maybe PHP is not ideal. So what do? You run an outside process out of PHP, and you read the results. Yes? What happens is that people tend to execute a process, wait for it to finish, and then execute something else, execute the PHP code. Again, we are facing the same problem. We are waiting for the process to finish, and once it does, we do something. Why are we waiting? Most of the stuff should be came back to us with pipes. This is probably the most important thing Unix has done. The most important piece of technology in Unix is the concept of pipes. So every single process in Unix has pipes. So it has a standard input pipe and two output pipes, a standard output and standard error pipe. And all the Linux, especially all the good written Linux tools, understand pipes. So if you want to read a file, you don't actually need to read a file. You just say, stream that file to me and process that. So, for example, in this case, let's say I'm downloading an XML, gzipped XML file and then unzipping that. This is not how you do that in Linux. This is a terrible way to do that. Why? Because I'm waiting for the file to finish downloading, and then I'm unzipping that. What happens, though, is that unzipping is possible without actually reading the whole file. I can stream out unzipping. So unzipping can work on blocks of data. So as long as I have a certain amount of data, you can unzip that and then keep moving. So it becomes faster. So the right way to do that in Linux is to do it like this. So I created a pipe which goes from the wget command straight to unzip, and whatever, like as soon as it downloads the first few bytes, it sends them to unzip. So in this case, you might be downloading a very large file, but you don't actually need to store it. It's only you're storing the actual result. Obviously, unzipping it is going to create a bigger file, but you're still not storing the temporary file. And you're also not storing anything in memory, because it just streams everything to that process. It's perfect. And you can combine stuff if you like. Then you can attach a grep command or a sort command or any sort of AWK filters, and nothing is being stored in memory. You can like any size of data, it scales. So how do you do that in PHP? Because if you run this exact code line using an exec or system or pass-through in PHP, it's not going to actually stream it back to you. It's still going to wait for that to finish and then give back you the result. So you're still missing out. There's a way well. It's pretty nasty. And I was trying to find the best way to explain that. So in this case, I have this example. I'm running the same wget command I showed in the slides before, but rather than executing and then waiting for it to finish, I'm creating a special proc open, which opens the process, runs it, and then returns me 3 pipes I'm able to read. So in a while loop, until I'm getting, until the file finishes, until I keep getting the results back, I keep reading them, and in this case, I'm kind of processing the XML file. So in this case, I'm kind of showing a very hacky way how you can actually process XML files just by reading them as a text. It's a very hacky way. It's only something you would do if you have really large files and they just don't fit in memory. Something, for example, I would use wget, I would use unzip, and then I use grep to only filter a certain amount of lines actually from that file, pipe everything back to PHP, and then run through this. It's a really, really cool way. In the same way, you can have ffmpeg processing a video, and it can be running, and your PHP script can be just reading the response, the standard output of that script, to be able to tell what's the status of the actual script. It's really, really powerful. And if you decide at some point that, wait a second, the results I'm getting no longer are actually good, you can just kill the process. It's really, really powerful and allows you to run outside scripts from PHP and still have this advantage of using pipes. Really, really cool. And I think if you've used any of the modern frameworks, especially Symfony 2, the process class they have actually does this. So you don't have to worry about this. But basically, if you're running exec yourself, you're wasting time. Another thing is, let me just have a sip. I found this bar which has like 10.5% beer. Oh, bad idea. So imagine you want to read from MySQL. That's something probably is the best use case. So you have a data store. You're storing a bunch of rows. You're running some sort of a result, and you want to read everything from that table. You say you want to build a report of some sort. How would you do that? What happens is that, I guess historically, PHP extensions were written what I would call in a bad way. They lie to you, because what happens is when you run a query on MySQL, it doesn't actually return results. What it returns to you is a pointer to a result stream. And then PHP extension reads that and eventually gets all the results, builds an array, and then returns it to you. Everything is fine. The problem, though, same thing I repeated again, you're waiting for a result to happen. If you're trying to get, I'd say, 100,000 rows out of a database, and that's not really that rare. If you have some sort of e-commerce, you're trying to export orders or users, you're waiting for a while, and also they won't fit in memory. So eventually there's going to come a time where you run a query, and you're showing so many results, like it doesn't even reach your code, and it just dies because it runs out of memory. Usually people increase their memory allowance on script, because basically they say, oh, this is running out of memory, let's just allow more memory to happen. That's actually a very good way to allow people to DDoS you, because if you allow a lot of memory to be allocated, I can just launch 100 scripts requesting your report, which returns me 100,000 rows, and all of a sudden you run out of memory on the server, everything crashes, I'm happy. So how do you do that? Actually, MySQL allows to return unbuffered queries. So rather than buffering them up and returning an array, it can return you resource. So that's the best. It works in Doctrine has support for that, and so you don't have to worry about that. But PDO has the same. That's just the most, I guess, my most concise example. So rather than running a query and returning an array, I'm running an unbuffered query, which means don't buffer the results. Return me a statement, a result statement, I'm just going to iterate through that and process that. If you combine that with the things I'm showing, I was showed before, rather than building some kind of an array here, just keep processing the row, all of a sudden, it doesn't matter how many rows you have in your database, you can process them very, very easily. And I've used that for reports and all sorts of stuff like that, because you can just stream results from a database as if you're reading from a stream, from a pipe, and everything works. It's really, really powerful. And you can also combine that to outputting data to users. That's something a lot of people do. You go to your application and there's like an export button. So you search, you click export, it generates you, say, a CSV file. CSV file is line-based. So you can, as long as you have 5 lines, you can give them back to user. So what we want to do is push results to user, assuming he's requesting them through a website. You can push them immediately as you have something. So if you looked at our example before, that's a bad example. So if you look at this, I'm generating the most simple I can imagine CSV file. So it's going to be a CSV file of all the names. I have an array of data, or a stream of data, or any sort of resource of data, and I'm generating a CSV file, which ends up being a string. This approach looks kind of fine. Everyone does it. But the problem is, what happens if you have a lot of data to export? You're building this a string of the results, which again, waiting for something to happen. Memory issues becomes a problem because you're building everything in memory. And also your user is waiting for you to generate that file, and then he's going to wait for himself to download that file. That's a problem. What we want to do is, as soon as we generate one row of data, send that to user. So as we are generating those rows, the user is downloading them at the same time. Saves everyone time, everything becomes faster. How do you do that? Again, in the most simplistic form, we echo the rows immediately, and then we flush the buffer. The default behavior in PHP, at the start of a script, it tends to enable the output buffer, so whatever you output to that, it stores it in itself. And all the frameworks do the same. I don't know why, it's just a very bad practice to promote. But they enable a buffer, so whatever you echo from a script doesn't actually get echoed until the script finishes and then it does everything in one go. In this approach, though, I'm echoing those rows, and it flushes them, so it actually sends everything back to the user. So, again, nothing is stored in memory. Perfect. I'm pretty sure most of the modern web frameworks allow you to do that the same. They allow you to create a response which is not being buffered. Everything goes back straight to the user. So, first of all, in this case, you can stream line-based files. You can also stream, if you want, which I don't recommend, you can also stream videos if you want, very, very easily. Because assuming you're reading one frame, you're maybe doing something, maybe changing a color. Theoretically, you can do that. You can change a color, and then you just take that frame and echo that back to the user and flush it. You can actually make PHP stream videos or stream GIF images or whatever you want, because you're never actually buffering anything. It's really, really powerful. The problem, though, let's go back to those infinite data structures. How do you actually define them in PHP? So in this example, I showed actually you need to kind of change your code. So rather than building an array, you inject process stuff, do those function calls. It requires changes to your application. And if you're using frameworks, it's not nice. And if you want to do ideally what you should do is you read something from database, you maybe do a bit of processing, then you echo everything back to the user. In all these cases, you have to take one row, process it, echo that to the user. Take one row, process that, echo that to the user. If you have a nice structure of using support of concerns or something you're doing in the model layer, control layer, and view layer, it happens that you actually need to change a lot of code to make it happen. It's really, really annoying. Although there's a solution. It's called PHP 5.5. Any of you using PHP 5.5? Good, because it's not even released yet. I was just checking. Maybe you're just lying. You're just yeah, yes, whatever you're saying. So, PHP 5.5. My favorite feature in PHP 5.5 is called generators. They look something like this in real life. It's a generator from a tank. They're called generators. What does it mean? They allow us to define data structures and data without actually pre-computing that data. It allows us to write lazy code. It comes originally, I think, mainly inspired by Python, because Python had that for a long, long time, Another language obviously has it too. I got introduced to that through Python. So how does it work? Imagine this is an old PHP, like an old PHP way. So here I'm creating an iterator, a class. If you instantiate that and you do a for each loop, it will keep generating numbers forever. This is a lazy code which defines an infinite array of numbers without actually ever storing more than one. Hard to imagine. But in no case am I actually building an array. Still though, I can access this as an array, which is really, really powerful when you think about that. The problem though is like, it would be nice to use the same sort of thing for my processing code. So my processing code just defines that I'm going to do something with a certain resource. I'm going to read some files, I'm going to give it back to you, but I don't really want to build those iterators, because if you want to apply the same sort of iterator which allows you to talk to infinite data structures for data structures and for MySQL results or data store results, it requires a lot of code. And I've done that before, and it's not nice. So what PHP 5.5 had introduced is called yield. And a yield is a pretty simple concept, but basically it replaces all the return statements in your code where you want with a yield. And what yield does is when the PHP executor calls yield, when the PHP executor runs through your code, when it reaches yield, it stops executing until you call next, which iterators do automatically. So it reaches that point and stops. Hard to imagine. I have a very good example of that. So imagine this. This is my code from the previous slide. So I'm processing a file. I'm reading all the lines, and then I process them and do something with them. How do you extract this to a function where I'm more flexible? I want to read the file. I want that function to return me a file, but not compute everything in memory, not store everything in memory. I can use yield. That's probably, I think that's the coolest example of my whole slide deck. When you call read right here, nothing is being executed almost. What PHP does, it goes to read, and then it goes through this function, opens the file handle, reads the first line, and stops right here at this yield statement. Then, if I pass this data to a for each loop, it will call next. And when you call next, PHP is going to be like, oh, next. So I return from here. Oh, it's a while loop. Okay, let's go back again. Oh, it's a yield again. I stop again. So what PHP does, it keeps executing this code until you call next. And then eventually you call next, it goes through here, this returns false, and so it goes back here and exits. So what this read function returns to you is something called a generator. This generator generates rows or generates lines from that file without having to store them in memory. Still though, you can interact with this as if it was an array. You can loop for that, you can slice that if you do it correctly, but nothing is stored in memory. And now you'll be able to do the same sort of stuff for all your code. So anytime you're looping for an XML file, for a data result, for anything, you can just keep yielding that, and in that way, you're going to create a pipe. Yield allows you to create pipes because you're defining what your data is. In this case, it's obvious that my data is an array of lines from that file. Nothing is actually, though, being stored in memory. It's a generator which is going to generate data as you call it. It's really, really powerful when you think about that, because you can very easily replace all your return statements, or replace your building of an array, which you're eventually going to return, just replace that with yield. And because in this case, in a normal case right now, 10 million? Did I win something? Oh, 10 minutes. It's like a prince probably offered me 10 million. So in this case, you would build an array, keep adding rows to that array, and then return that array. In this case, I replace everything with yield. Nothing changes in my code after this, but my function becomes a generator. Really, really powerful. Another good example I like is how do you request stuff from the internet efficiently? So say, rather than reading files, rather than reading database, how do you get data from web APIs or files stored in the web? So you need an efficient way to make HTTP requests. And if you want to do a lot of them, if you want to read a lot of files, if you want to do something on a kind of a larger scale, eventually there's going to be a problem because you're going to run out of connections. Linux or TCP/IP works in a way where even if you close a connection, it still open. It still stays open for at least 2 minutes because maybe a packet will arrive later. So it needs to understand where that packet was supposed to go. Even if if you're not interested anymore, Linux kernel still needs to know. So if a connection stays open for 2 minutes, and roughly you can do 20,000 open connections in Linux kernel, you can calculate how many connections you can actually make until you actually run out of space. And that's something we had. Is like if you request a lot of things, how do you make PHP scale, pretty much? And the only right way to do that, and I couldn't fit it in a slide well, is actually if you use curl multi-extension. That's the only way how you can have a connection to the server open, and you keep requesting things without actually closing the HTTP connection, which is really useful because first of all, you get rid of an overhead of having to open connections, do everything again and again and again. In this case, you actually are able to reuse a connection and not run out of open connections. It's really cool. So if your processing problem is reading a lot of things from the web, being it web scraping or just requesting some APIs, this is a very good way to optimize things. I think the PHP library called Guzzle does that, and pretty much all the other PHP frameworks and libraries tend to not to do that. So if you actually try to use them and request a lot of things very, very fast, it just breaks. Your Linux kernel starts dropping connections and the whole thing just collapses. So we talked about a few things. Eventually, though, you're going to come with a problem where it's still not good enough. So you optimize your PHP scripts, everything is running as fast as you can probably make it. Still, you're having problems actually scaling things. So what are the next quick steps you can make? First of all is Gearman. So a very nice tool was created. It allows you to separate the processing of something and the request of something. So rather than having a sequential script where like I'm reading a file, I'm processing every row, I'm doing something, with Gearman, you create a job queue where I read for every line, you submit that to a job queue, and then there is a list of workers which go through your whatever jobs you have submitted to them and process them. So using Gearman allows you to write PHP code which is asynchronous. Because when you can request things, for example, if someone uploads you an image, you can create a Gearman job rather than processing the same script as you're building the website response. You can just say, Gearman, do that later, and it eventually is going to create a thumbnail for you, upload to Amazon as free, but your main script is not being delayed. So Gearman is a very good way to scale by building asynchronous processing. So if you need to do function calls which don't necessarily have to happen right now, you can just offload them to asynchronous processing. And then the PHP script exits, and then there's still something happening in the background. But when it comes to data processing, Hadoop is like the solution. So it was something which was created by Google initially, or it was an idea by Google initially. And what happens is, imagine a very large data set. So large data set, but it doesn't fit in one server. How do you handle that? People used to shift around data, just take data, copy that to the server, like copy across servers, do something. That's not scalable. So what Hadoop does, it takes data and splits it into servers, and then takes your scripts, deploys them to those servers, run them locally, and then takes the result, combines that, and eventually turns a big result. So with Hadoop, even if your data sets are incredibly large, whatever the size is, it runs a thing called an algorithm called MapReduce. It allows to run a function locally on a server and then reduce the result to a final result. So, like I didn't have time to go through Hadoop and Gearman in good detail, but if you're having problems with data processing and if you need to do things quickly, this is the right way to do that. You might be thinking though, why PHP? Because PHP is obviously not known for incredible performance or whatever you're doing, so why would you do that? For example, it's not possible in PHP to allow user to upload an image, or at least not in a clean way, upload you something, and while that file is being uploaded, you're able to read that. So if someone uploads you a large file, you actually want to start processing that immediately. You don't really want to wait for that upload to finish. And that's really not easy to do in PHP. Although, for example, in our case, we use PHP for a lot of things and for really large systems. And so why would you use PHP? Because applications start off by being written in PHP, and actually you can scale PHP as long as you drop using those simplified solutions, like simple XML is a good one, file get contents, all these things which buffer data into final results end up being something which causes your application to just crash eventually. It just happens. So what's possible? You can do PHP for a lot of things. So we've built PHP web spiders which process 100 million pages a day. We've built PHP scripts which process gigabytes of XML files in a second, because you can do that as long as you use streams. PHP is extremely powerful as long as you realize the concept of pipes. So PHP is not really a limiting factor when it comes to data processing, but as long as you understand that you try to avoid building things in memory, it scales. So using it for good. The best example I've had of that is that imagine your user uploads you say a price list, and your result is supposed to be another spreadsheet generated from that data. So the best way to do that, user uploads a file, and as soon as you start getting every single line of that file, you start processing that. You yield results. You don't build an array. You keep yielding them, and eventually you start echoing things and flushing that to the browser. So I can allow users to pretty much upload any size files to any system, and they're not going to crash our system, and we can generate infinite amount of results. Thank you for your time.